Okay, so normally in a traditional face-to-face class, I would start the class by collecting students' homework and asking students if there had been any questions that students struggled with on their homework. And I would start the class by going over those problems. In that way, it's more productive because the problems are still fresh in students' minds, and it'll help them to get forward with the upcoming lesson. But since that's not the case, and as of today, which is Saturday, I've noticed only one student had turned in the homework. So I don't know if I have assigned too much homework for the first week. So to get sorted out, I posted our discussion board question asking you guys about the workload for the first week. So if you guys can answer that, that would be helpful for me. So instead of going over the questions that was covered in chapter 0, which really is the preliminary materials that should have been covered in your previous math courses prior to discrete math, I'm going to go over some of the problems that will be covered in the second homework. So the reading is section 1.1 to 1.3 for second week, and I will be assigning problems 1, 2, and 3 on page 38. So problems 1, 2, and 3 has lots of parts, so lots of subparts, so we're going to go over some of these problems in this video. Okay, so let's start by, I'm going to go, okay, so page 38, let's do some problems on number 1. So number 1 has 4 parts. Let's go over A. So A is y prime equals to e to the power of 3x plus sine of x, and the domain given is all real numbers, which means it's going to be on negative infinity and positive infinity. All right, so we have to find all solutions to the following equations for this given equation. So this is strictly asking if students have read on page 36, part 3. So the given definition of our textbook is y prime is going to be f of x, where f of x is continuous. So this is section 3. This is equation 3.1 on page 36. So we're going to use our good old calculus and do integration of both equations. All right, so if you do that, we're just going to get y, or which is in this case is going to be the same thing as our function. And we're going to get 1/3 e to the power of 3x. And we're going to get, instead of sine, that's going to be cosine of x. And what's important with our ordinary equations, differential equations, is that we're going to have some kind of constant that we don't know. And this will play a pretty integral part going forward, so please do not forget to write that. And I think this is it. This is our solution for our first problem. So this is a kind of review of the previous calculus classes that you guys have also taken. Okay. All right, and you guys can mention that c is any constant, but we all know that as of now. All right, so that's done. Maybe we can do one more. Let's do D on the same problem. So number 1, D. Okay, so D has been differentiated 3 times. So we have triple prime equals to x to the power of 2. So we're going to do the same thing. We're going to integrate both sides first. So I'm going to start by doing this. All right, so that's going to give us y double prime. That's going to be equal to 1/3 x to the power of 3 plus c. I'm going to call this constant 1, the first constant. And I'm going to integrate both sides again. Do that. And at this time, we're going to get y prime. That's going to be 1/3 times 1/4 x to the power of 4 plus c1x plus c2. We're going to get a second constant. And this becomes 1/12. All right, and then we're going to do the same thing. Integrate both sides again. So that is going to be, we have 12, and we're going to be left with 1/5 x to the 5 plus c1 over 2 x to the second plus c2x. And don't forget about our last constant. And that's it. That's how we find. This is like the simplest form of the differential equations that we're starting. Okay, so this is our answer for D. And of course that fraction is going to be 1/60. Okay. So please try B and C on your own. Feel free to do over A and D when you're turning in your homework. Okay, and let's go and do some more problems. Okay, so let's do a few problems on the same page, number 2. So, all right, so this is the proving of the questions. So let me start by doing A. So A is given as, this is the function, as e to the power of negative sine x. And we have to prove that for y prime plus cosine of x, y equals to 0. So in this case of the proving, I would take one side, so this is either the left-hand side or the right-hand side, and then plug things in and try to get to the other side. So what that means is, let me start by differentiating. So I'm going to differentiate both sides of the given function. So that's going to have our y prime is going to be negative cosine of x e to the power of negative sine of x. Simple chain rule. All right, so we have that, and what we can do now is we can substitute this in here. And then what we can do with this y is we can substitute our given y in right here. Okay, so after we do that, we have, so this, I'm going to call this as our left-hand side. So how you guys will do the proof is that left-hand side is going to be equal to negative cosine of x e to the negative power of negative sine x plus cosine of x, and I'm going to substitute e to the power of negative sine of x, and let's see if we can get to 0, which is our right-hand side. All right, so it looks like this is the same thing with just different signs. So this indeed, we have a negative cosine of blah, 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 and the positive value. So this is going to equal to 0, which we have landed on the right-hand side. And this is it. That's like a symbol that QED, you have proved that the given equation is true. Okay, so let me do a couple more. Let's do a few more problems on number 2. Let's pick, let's do B. All right, so B is also given as a function sine of x minus 1, and we have to prove that y prime plus cosine of xy equals to sine x cosine of x. Sorry guys, this is way too similar to the first one we did, so instead of this, let me do something else that looks somewhat different. So instead of B, let's do E. Okay, so the E states that this given function that we have is C1 plus C2, e to the power of x. And we have to prove that y double prime minus y equals to 0. All right. So from this given function, let's find the primes. So we differentiate once both sides. So y prime, that's going to be, this is a constant which is going to get knocked out. So we don't have it. And from this, our C2 gets kept and EX differentiated just becomes EX. So there we go. All right, so from this, let's find the double prime. Let's differentiate it again. So this is our first found equation. And if we differentiate again, our good old calculus gives us that the constant will follow, and we're still going to have e to the x. All right, so we have these, and I think you guys can write out the rest. With this, we can start out with this as the left-hand side. So try to get in the practice of writing these kind of proofs. It's super clean. So we have y double prime as c2 e to the x minus y prime is c2 e to the x. They're exactly the same thing. So we did end up with 0, which is the right-hand side of the given equation that we are asked to prove. And that's it. All right, so I think pretty much the rest you guys can attempt, and I don't think you should have any trouble doing this. And let me go over number 3. Okay, so for number 3, consider the equation y prime plus 5y equals to 2. First, you have to show that the function of x is 2 over 5 plus c e to the negative 5x. So instead of me doing this, so they're saying that this one is the solution, and where c is constant, so you have to show to get here. All right, so how would you show that the equation, the solution to this first order differential equation, you're going to get there? So that's the first asking questions, and it's pretty similar to the first 2 questions in the practice that we would have done. And second question. So to give you a hint for part A, I guess you guys can go backwards. You guys can take this, find the first derivative, plug it in here. All right, so the hint is that find y prime and then plug it here for right here. Then plug in this original, this one, into here, and then see if this equation holds true, and therefore that's how you guys would do A. For B, assuming every solution has this form, find the solution satisfying. Okay, so you guys are given a constant of 1 equals to 2. So your job is to find C. So if you plug in 1 here into the given formula, then your equation here is going to be 2 over 5 plus c e to the power of negative 5. And we know that this is going to be equal to 2, because in the problem of B, this is 2. Now you guys can find what C is. Okay. And part C, find a solution satisfying the function of 1 equals to 3 times function of 0. I think you guys, this is a good problem. I think I will leave this part up to you guys as a challenge. And that's pretty much summarizes what the homework is going to be for week 2.